Hello, this is my English speaking practice. I solve problems on LeetCode, and today I'm gonna work on subset 2. This problem. Let's go. Given an integer array, given an integer array nums that may contain duplicates, return all possible subsets. The power set. The solution set must not contain duplicate subset. Return the solution in any order. So in this case, the nums is 1, 2, 2. So we should do choose 1 or not, and choose 2 or not, and choose 2 or not. So when we don't choose at all, this is the answer, and choose only one, and choose 1 and 2. But there are two patterns that becomes 1, 2. Choose 1 and choose first 2, and choose 1 and choose second 2. But the solution set must not contain duplicate subsets, so in this case we should return 1 and 2 pairs. Yes, but we can use 2 2s, so we can return 1 2 2 and 2 2. Yes, and the length of nums is from 1 to 10. Yep. And the number values ranges from -10 to 10. Okay. Subset 2. Import list from typing library. Subset with duplicates. Yes. So let's think about this case. Basically, I'm wondering, I use backtracking because the process we have to implement is choose or not. So after first choose 1 and explore for remaining, and after finish exploring, remove 1, that is backtrack and go next. If we don't have to think about duplicates, the backtracking might be a solution. So let me implement a naive solution. Yes. So we prepare the array to hold the results, and the backtrack function takes current as a list of integer. Yes. But wait. Okay. Maybe we don't need to use backtrack. Because we explore all combinations, so don't need to backtrack. Right? Yeah, it's simple. This is simple because there is 1, 2, 2, and choose or not choose. Choose or not choose, and choose or not choose. So yeah. So there are eight patterns, 8 combinations. It's because there are three numbers, so the number of answer is 2 power of 3, which is 8. Yes. Yeah, but this is when we don't think about the duplicates. Okay, so first of all, I'd like to implement exploring these combinations. So let me think about this. 1, 2, 2. The recursive function would be good for this program, and it takes the current index and in the function it called two patterns, right? So the current list of integer, it takes current list of integer and call Yeah, so here we want to clone the current arrays. So in this we copy the array here and plus nums edx. This is the plus pattern, so that means choose the element, and the other calling means don't take the number. So yeah, we just increment the index. Yeah, so look at the next index, and the current list of integer doesn't change. And finally, if the index is length of the arrays, it means we finish exploring. So yeah, we append the current list, and we don't need to clone the array because there is no backtracking, so this array is no longer used after this. And we start with index 0 and the empty array. Yeah, so in this with this solution, the answer contains the duplicate subsets, but I want to check it. So let me run the test code. Oh, this is car plus. Okay. Yes, as expected, maybe 1 1 2 1 2 and 2 2 2. Yeah, there is a duplicate, so we have to remove these duplicates. How to do that? Okay, the simple solution is using set, because yeah, we want to remove the duplicates. So if I use set, we can remove the duplicate elements from this. Yeah. In order to use set for here, the element should be hashable. Yes, but the list is not hashable, so we have to change it. List to tuple. Tuple is a hashable, so we can use the tuple as an element of the set. This is good. Let me think about another solutions. Yeah. I don't come up with another solutions. So let me do that. And how to type the tuple and curve is. So we use add function and curve. So we don't, the tuple is copied when use this when use this signature. So we don't do like this, but yeah, a little tricky. For adding tuples is like this in Python. Yeah. Let me 3 empty tuple. Maybe we can like this. Yes, so finally we have to cast the type to list. Great. Yeah, but the tuple is, I think tuple has an order. 1, 2, 1. So the one so the problem requires to remove duplicate subsets. How about 2 1? 2 1 and 1 2 are the same or not the same? Yeah. Yes. So the problem requires expect the 1 2. Yes. But the tuple recognize they are different 1 2 and 2 1. So the answer is like this. So in order to avoid this case, we just sort the original array. With this, we can remove, we can remove 2 1 or like that. So we just get 1 2. Okay, cool. Any other edge cases? Length is 1. Yeah, seems good. So submit it. Great work. But I'm curious about other solutions without set. Or like this. And this solution use backtrack. And at the base case, copy the path and append it to the answer. And branch 1 and branch 2, the branch 1 is including current index and go next, and branch 2 doesn't include current index and its duplicates. So since this is a backtrack, we pop it from the path at first, and after that, I see. Skip duplicates. That makes sense. This is smarter than mine. Yeah, I think this is ideal answer. Okay, let me write a solution without set. Since we want subset, power subset, so we can use backtrack, and it takes index of the arrays, and it takes current index, current list of integer. That means current path. And the base case is like this: index equals to length of the array, and we declare the array for storing answers, and the answer is like, yeah, current path, but we have to copy the array because we use backtrack, so the branch 1 and branch 2, and the branch 1 includes current number. So yeah, include and remove the current number from the current path. And the backtrack is like, before calling backtrack, we have to think about the duplicates. For example, choose 1 and okay, choose 1 and choose 2. For at the branch 1, we choose 2. We choose the first 2, and so the exploring the path 1 2 2 and 1 2, and after that we we are here. We are here. And in this case, in this case, we cannot append the path append this path, because at here we decided to not use these two. So from here we cannot use 2. So if the next number is the same, we don't go to, because we finished exploring with 2. So in this path we cannot use 2 anymore. So we have to check the next number, right? Yeah, we have to check the next number. Because we don't use the number, we don't use the same number. So if it's same, increment index, and if it's not same, we can call the next. Oh wait, how about this? Yes, maybe EDX plus 1. This EDX is 2. Yeah. Okay, guys. Maybe like this. So we go next, but we have to I'm confused. The EDX points here, and we this path means the EDX points 2, but in this path we don't use 2, and the basically we just increment the index, but the next index at the number at the next index might be same as the current number. So we have to think about this. So the EDX, we have to check the current index and EDX plus 1. That's correct. That's correct. And after this while loop, the current number and the next number are not same, so we can call like this. Yes. And if it's same, we increment the index so it point here, and we check next. If it's not same, the index points the different number, so that makes sense. Okay, that's it. Backtrack, EDX, and 0 and empty list, 0 with empty list, and return answer. Okay. Great. So, time to learn English. We sort the array so that we can handle duplicates easily. We prepare an array to store the results. Here is the base case. If the EDX is same as length of the array, we we copy the corpus and append it to the answers. Since we use backtrack, which use car path later. We use backtrack since we use backtrack which use car path later. Branch 1 include current number. Yeah, so we append the and go next. Backtrack here. We from the current path and to avoid duplicates. We go we increment edx until the number at edx defaults from current one. Backtrack. Yeah. Because in this path we decided not to use the current number, so we have to avoid the number. We sort the array first, that way duplicates are easier to handle. We sort the array so that we can handle duplicates easily. We prepare an array to store the result. We'll keep a list called ans to store all the results. Here is the base case. If edx equals the length to the array equals if edx equals the length of the array, we copy the car path and append it to the answers. We copy the current path and add it to our results. Broken grammar. We make a copy because backtracking will keep modifying current path later. First branch, we include the current number, so we append the current number to the path. We push the current number onto the path. Then we move on to the next index. Second branch, skip the current number. Since we are backtracking, we remove the last number from the path. Awkward phrasing. To avoid duplicates, we keep moving index forward until we see a different number. We see a different number. Since in this branch we skip the current number, we need to skip all its duplicates too. Here's the base case. If the edx equals the length, this we use. Okay, go next. Reverse linked list 2. Given the head of a singly linked list and the two integers left and right, we are left equal left is right or less. Reverse the nodes of the list. Reverse the node of the list from position left to the position right, and return the reverse list. Okay. I understand the problem. Problem clarification. So we take three values, the head of linked list and the left and right, and the index is one indexed. So left is 2 and right is 4, so it points here and here, and we have to reverse it. We have to reverse it. Yeah. So let's think about the example. Reverse. So we wanna pivot. We want pivot, and yeah. The 2 should connect to 5, and 1 should connect to 4. Okay, so yeah, introducing 2 pivot. Yeah, before left one and after right one, we introduce 2 pivots. Yeah, and it works well, because yeah, after reversing the ranged linked list, we have to update the next pointer for edges, for edge nodes, right? Yeah. How about this case? And left and right are the same. We cannot do anything. One, two, three. Might be okay. So, okay. Let's go. Yeah, we iterate the linked list. So but wait, we use scanning pointer. It initialized with head, and while scanning exists, we check it. And we count the index. Yeah. If count equals left, we wanna introduce the pivot node. And also we have to keep track of previous node. We have to declare two pivots. If count equals left, we can initialize the left pivot, and the next gonna be scanning node. and oh wait, how to no. Left pivot should point to previous node, right? Yeah. And the scanning next gonna be left pivot. Right now. And if count equals right, yeah, we have to keep track of the right side of right side of the right pivot. So the it means right pivot connect to these nodes, so we can initialize like this, and the next is scanning, and if the right pivot and scanning next gonna be previous. Okay. Oh, wait. We have to move pointer forward. Move scanning pointer forward. So the scanning gonna be scanning next. Scanning next. I see. We point the scanning next. The scanning next should point the right pivot. Yeah. How about this? 1, 4, 3, 2, 5. Oh, we don't need to do. Yeah. Because we can know the left pivot and right pivot anytime, so we don't need to point the pivot. Pivot just point to something. Maybe this one. Because we have to know about the both side of the node. So the pivot points those of them. Scanning next. Stamp and update the scanning next to previous nodes. this is a little bit complicated. In this case, yeah, yeah, in this case, we have to update the scanning next pointer. So the we keep track the scanning next pointer as a temporary variable, and we update the scanning next to the previous node, and the previous node gonna be current scanning node, and the scanning node gonna be scanning next. Yeah, but in this case we keep track of the scanning next as a temp variable. Yeah. And the count is more than right. We don't need to do anything, so the condition is like this, and increment count. And after the while loop, we can get we can get like this. We can get like these nodes. So we update before left node is left pivot next. This one, the before yeah, before left before next before left point to this. Oh wait, how to find this? Okay. I see. Before left point to the right pivot next. Yeah. And we want to maybe we should prepare 3 pivots. and the left node is left pivot to next, and the left node should point the scanning, because the scanning pointer points the after the right node. And we have to handle edge cases. Pivot nodes works. Yeah. Okay. We have to handle when the head is none. Because we cannot cover it, the main process. When the left and right is the same, it's like this. So the left before points the this, and the left pivot, left node point scanning. So 1, 2, 5. Yeah, so it doesn't change. It's correct. And how about left is 1. Like this. Hmm, 4, 3, 2, 5. Yeah, we can cover it. We can cover it. So I think this is good. Left pivot doesn't. Really? Oh. Count is right or less. Right or less. Let me see the result. Great. Perfect. Okay, I will finish.